This is an overview on Lesson 6. Our main vocabulary includes conditional probability. So this is the calculation of a probability that occurred after a certain event occurred. For example, the probability of A given that B occurred, which is written like this, is a conditional probability. Now, some formulas that you would use is probability of A and B equals probability of A times probability of B. Probability of A given B equals probability of A and B over probability of B. Probability of B given A equals probability of A and B over probability of A. Probability of A given B equals probability of A, and probability of B given A equals probability of B. Notice that these three equations are only true if the events are independent. These two equations are only true when the events are independent, because when the two events are independent, then either event occurring first does not change the probability of the other. So here's an example that will set you on the right track. Flipping tails on a coin and rolling 1 on a 6-sided die. These are the probabilities of these two occurring. Calculating the probability of A given B and probability of B given A, we find that this is equal to probability of A, this is equal to probability of B. These two equations are true. And to figure out the probability of A and B over probability of A times probability of B, using substitution and figuring out this equation in terms of probability of A and B, we find the probability of A and B was probability of A times probability of B if the events are independent, so this equation also holds true. Ready? Okay, move on. Now this is a practice problem. Complete the Venn diagram, which has already been done for you for the sake of time, and determine the probability and if they're independent or not. So the values less greater than 2. So event A, 1, 2, 3, 4, and out of the whole 6 numbers on the die, that would be 4 out of 6. Probability of B, which is probability of even numbers, 1, 2, 3, 3 over 6. Probability of A and B, which is 4 and 6. Those are two numbers, so 2 out of the 6 numbers. This can also be written as probability of A intersection B. So set A intersection B, so just writing the set, it would be 4 and 6 because those are in the intersection or where they meet. Now this probability of A given B. So given that B has occurred, there's 3 numbers that have occurred. Of those, 2 of those numbers also fall under event A as they're in the intersection, and intersection basically means it's both event A and event B. So out of the 3 numbers that occurred, 2 can be part of event A, so the probability of A given that event B has occurred, 2 over 3. Probability of B given A, event A has occurred, 2 of those numbers can also be part of event B. Out of these 4 numbers, so the answer is 2 over 4. That was using the Venn diagram. In the next question, we will be actually using the equation and find that it equals the same thing. Now, are they independent? Well, this does not equal that, and this does not equal that. Therefore, they are not independent, which makes sense because if it was this, then it would affect this, and if it was this, then it would affect that. They're not independent. Now, this is a similar scenario. Give it a 6-sided die, but this is different numbers. So this is odd numbers less than 5 and numbers less than 3. So probability of A, 1, 2 out of the 6 numbers. This would mean this would be 2 over 6. Probability of B, 1, 2, 2 over 6. Probability of A and B. There's only one number, and that falls under both categories. That's 1, so that would be 1 over 6. So set A intersection set B, that would be the number 1. Now let's use the equation to solve for this one. Probability of A given B. So the probability of A and B would be 1 over 6, and that would be over probability of B, which is 2 over 6. And this is equal to 1 over 2. And coincidentally, looking at the model, 2 numbers, only 1 fits under both event A and under B, 1 over 2. In a similar scenario here, 1/6 over 2/6 equals 1 over 2. The equations work, and so does the Venn diagram. Now here are some common errors. The probability of A given B. So this is the probability of A given B. This is the given, and this is what we have to figure out. It's not the probability of B given A. It's not going to be this way. It's going to be that way. Now, this means intersection, and this means union. Intersection is this, union is everything in the Venn diagram. So when you're calculating the probability of A given B, you ignore event A, and you look at just event B. So if event B has occurred, probability of A would be, falling under A, would be the intersection, as that's part of both event B and part of event A. If B has occurred, then it has to be part of the intersection to also be part of event A. I hope that cleared up some common misconceptions.